Assalamualaikum. We Group 9 will do a video about cache mapping for subject Csci 1302 Introduction to Computer Organization. But before we start, I will show you the task distribution between our group members. I am Anisafia with matrix number 2116330 will do an introduction of cache memory. Nur Shaira will talk about direct cache mapping. Nur Shakira will talk about associative cache mapping. Hana Kamalia will present about associative cache mapping. And Nur Ain will talk about cache levels, types, and application of cache memory. To understand what is cache mapping, we must first find out what is cache memory. It is a very high-speed memory with small amount of fast memory that may be located on CPU's chip. And why is it so important? It will speed up with high-speed CPU. It is an extremely fast memory that acts as a buffer between main memory and the CPU. It will also reduce average time to access data from main memory. Now, I will explain a little bit on cache memory principles because it will be used in the next part frequently. They have block, frame, line, tag, and line size. Block is the minimum unit of transfer between cache and main memory. Frame distinguishes between the data transferred and the chunk of physical memory. Line is a portion of cache memory capable of holding one block. Tag is a portion of cache line that is used for addressing purposes. Line size is number of data bytes block size contained in a line. So cache performance, how does it work? When the processor needs to read or write a location in main memory, it first checks for a corresponding entry in the cache. Data will be read from cache if processor finds the memory location in the cache, which is called cache hit. If not, a cache miss has occurred. Cache will allocate a new entry and copies in data from main memory. Now to our objective of the video, which is cache mapping. So there are three cache access methods, which are direct mapping, full associative mapping, and set associative mapping. And now my other group members will explain more on cache access methods or cache mapping.
Hi, I'm Nashaira and I want to explain about one of the category of cache mapping, which is direct mapping cache. Okay, what is direct mapping? Direct mapping is a procedure used to assign each memory block in the main memory to a particular line in the cache. If a line is already filled with a memory block and a new block needs to be loaded, then the old block is discarded from the cache. In the parts of main memory, termed as blocks, and the parts of cache memory are named as lines. Also, the line size is as same as the block size. Now, the smallest addressable memory unit is called a word, and a byte addressable memory means the size of each word is 1 byte. Let's see the example of direct mapping for better understanding. Let's assume we have a main memory with 64 word size, and the size of each block is given as 4 words. Hence, the number of blocks in main memory is 64 by 4, that is 16, so that blocks are numbered as 0, 1, 2, 3 up to 15. Now, coming to 64 main memory words that starting from 0 up until 63, they are organized in the main memory because each and every memory block is supposed to have only 4 words. In order to address 0 to 63, that is 64 words, we will be needing log 64 base 2, which is actually result in 6 bits. Now, these 6 bits are called PA bits or physical address bits. And the reason behind that is the main memory sometimes referred to as physical address base, and in this particular physical address base, that is 16 blocks, and in order to locate each of them, we will be needing log 16 base 2, this is log 2 to the power 4 base 2, which is 4 bits used for identifying the blocks, and the least significant 2 bits are used for addressing each word in each block.
My name is Nur Shakira Huda and I will be introducing about the details of fully associative mapping. So what is fully associative mapping? It is techniques that allows mapping of the main memory block to a freely available cache line. It also permits the storage of data in any cache block. Now, let's assume that the random access memory is the size of 128 words, while the cache size is the size of 16 words. The cache and the main memory are divided into lines and blocks respectively. Also, it is the size of 4 words for every block line. Physical address. Since the block offset represents the block size, so 4 words of block can be represented through 2 bits. While since the block number represents the block in the main memory, there are a total of 32 blocks in the main memory. 5 bits would be required here to represent 32 blocks. We do not need to divide the block number into line numbers and tags. In case there are a total of 128 blocks and the size of every block is 8 words, then tag is equal to 7 bits, block number is equal to 7 bits, and the block offset is equal to 3 bits. Searching for a block through tags. Since the required word of the memory block can be present in a line of cache, the number of the comparator is increased. If you match the tag of the given address with the tags of all the cache lines, then it is a case of cache hit. Or else, it is a case of cache miss. So the shortcut formula is, the comparator is equal to total number of lines, and the physical address is equal to the total of block offset plus the tag.
I'm Hannah Camilia. We'll be explaining about set associative mapping. Okay, set associative mapping is an enhanced form of a direct mapping where the drawbacks of direct mapping are removed. Set associative mapping is a combination of advantages of both direct and associative mapping. And cache memory contains a number of lines that are divided into a number of sets. Each set have the same number of lines. The way is specified where one set equals to k lines, and it is called as k-way set associative mapping. Okay, a particular block of a main memory can map to only one particular set of the cache. However, within that set, the memory block can map to any freely available cache line. In set associative mapping, the physical address is divided as tag, set number, and block. Okay, set associative cache employs set associative cache mapping technique. After the CPU generates a memory request, the set number field of the address is used to access particular set of the cache. The tag field of the CPU address is then compared with the tag of all k lines within that set. If the CPU tag matches to the tag of any cache line, a cache hit occurs, and if the CPU tag does not match to the tag of any cache line, a cache miss occurs. In case of cache miss, the required word has to be brought from the main memory. And if the cache is full, a replacement is made in accordance with the employed replacement policy. And that's all for the set associative mapping. Thank you.
Hi, I am Ryan and I'll explain the application of cache mapping, types and levels of cache. A cache is divided into two types, which are primary cache and secondary cache. A primary cache is always located on the processor chip, while a secondary cache is placed between the primary cache and the rest of the memory. I will explain more about this in levels of cache. CPU cache comes in 3 different levels, level 1, level 2 and level 3. The first level is level 1 or known as the primary chip. It is always located on the processor chip. Moreover, it is the smallest and the fastest to access. Among other caches, the level 1 cache is the fastest cache on computer. The next level is level 2 or known as secondary chip. It is placed between the primary cache and the rest of the memory. In an early computer, the level 2 cache was located on a separate chip on the motherboard, but now it will be housed on the processor chip. This cache is used to cache recent data accesses from the processor that were not caught by the level 1 cache. The level 2 cache is larger than the level 1 cache, but is slower than it. The last one is level 3. It is used to cache recent data accesses from the processor that were not caught by the level 2 cache. It is the slowest cache compared to level 1 and level 2 cache, but the biggest cache. Level 3 cache is also located on the processor. In short, if the CPU can find the data it needs in the level 1 cache, it then searches for the data in the level 2 cache. And if the CPU can find the data in the level 2 cache, then it searches in the last level of cache, which is level 3. And finally, if level 3 doesn't have the data, then the CPU has to go back to the slow RAM to find the data it needs. Application of cache mapping. Usually, the cache memory can store a reasonable number of blocks at any given time, but this number is small compared to the total number of blocks in the main memory. The correspondence between the main memory blocks and those in the cache is specified by a mapping function. So, that's all from us. Thank you for listening. Bye!